Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Today in this class I will teach you all the graphs related to the motion in a straight line, that is kinematics in 1D. Students, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the IIT exam and NEET confidently with a good rank. Now let's start about the class. Today I will discuss all the graphs related to kinematics in 1D, that is motion in a straight line. Now some basic graphs. First we know some basic graphs. Suppose x-axis, this is y-axis. Now y equal to, this is mx, where m is a slope, and so y equal to mx is a straight line passing through the origin. Suppose y equal to 2x, y equal to 3x, all the graphs will be this. If the value of m increases, then the slope also increases. This. Suppose this is y equal to x, this is y equal to 2x. So as the slope increases, the graph, the straight line shifted towards the y axis. So suppose this is y equal to x passing through the midway, y equal to 2x slightly tilt towards the y-axis. So as the value of m increases, the graph tilt towards the y-axis. But all the graphs passing through the origin. Now y equal to x will be this. Y equal to minus x will be this. This is y equal to minus x. So you have to remember all the graphs shortly. Now suppose is a straight line, y equal to minus x plus 4. You have to draw this. So to draw this, all the graph, you have to express in terms of x by a plus y by b equal to 1. So this is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Plot the point 4, 0, 0, 4 here and draw the graph. So to draw the graph of straight line, you have to express in terms of x by a plus y by b equal to 1. This will be more convenient. You have to, if you draw the graph with slope and intercept, this is longer and more difficult, but if you express in this form, then to draw the straight line, it will be more convenient, more easier. Okay, suppose you have to draw 2x minus y equal to 4. So how will we draw x first? So here a intercept is 2, y intercept is minus 4. So graph will be 1, 2 here and towards the negative minus 4, 1, 2, 3, 4. So draw the graph in this way. This is x-intercept 2 unit, and this is y-intercept 4 unit, and draw the graph passing through 2 points. So I have discussed in another video all the graphs of straight line. Now suppose y square equal to kx, k is a constant. What will be the graph? Y square equal to x. This is a parabola. This graph will be this. This is x, y. This graph will be y square equal to kx. Now, what is the graph of y square equal to? What is the graph of x square equal to ky? The graph will be this way. This is the x square equal to ky. This is x, y, this. Suppose y equal to x square, only y equal to x square. So obviously we have to y equal to x square means this. If k is here, then the graph will be in this way. So y equal to x square, graph will be this way. Y equal to x square, and y equal to x cube. Y equal to x square, y equal to x4 y equal to x to the power 4 6, that is when power is even, then the graph will be this. Suppose y equal to x square, graph will be this. If the graph will be this is y equal to x square, y equal to x to the power 4, this is y equal to x square, y equal to x to the power 4, the graph will be more this y equal to x to the power 6, graph will be y equal to x to the power 6, graph will be more narrow towards the y axis. To understand that, y equal to x square flat, y equal to x to the power 4 more narrow towards the y axis, y is more narrow. So if power increases, narrowness becomes increases towards the y axis. Now what is y equal to x square? This is, if the power is even, then the graph will be symmetrical about the y axis, and if the power increases, the narrowness towards the y axis become increases. Okay, next y equal to, suppose x cube, this will be graph y equal to x cube, this is x, y. Now the graph will be this way, y equal to x cube, graph will be this way. Now y equal to x to the power 5, graph will be more narrow, so narrowness become increases like this way. Now this is the power graph. Y equal to sin x, sin x graph you have to know. This is x axis, y axis, sin graph will be this. This is sin graph. And what is cos graph? Cos x graph will be this. When sin x 0, cos x maximum. When it is pi by 2, when pi by 2, this is 0. So graph of cos x will be this. When this is pi, cos pi equal to -1. This is 3 pi by 2, 3 pi by 2 will be 0. So cos x graph will be this way. This way. So if we draw the line through the point A and B, so this will be the tangent at A, now A and B coincide, so this become the tangent at A, because line touch at the point A, so touch at the point means this becomes tangent at A. So now slope of xt graph equal to velocity, displacement time graph, distance time graph become speed, displacement time graph become velocity. Now slope of, this is the one theory. Next theory is slope of VT, velocity time graph, velocity time graph. Okay, velocity time graph equal to acceleration. Next theory, area of distance, area of displacement time graph, time graph represent distance travel, or sometimes displacement travel. Displacement time graph, we can measure distance travel from velocity time graph or displacement from velocity time graph. And next theory is area under VT area under AT graph, A versus T. AT graph means acceleration time graph. Acceleration time graph. AT graph. E denotes what is area under AT graph. Area under AT graph is change of velocity. Change of velocity. Area under AT graph is change of velocity. So this is the theory. Now I have discussed already what is slope of a line and some basic theory. Slope of xt graph equal to velocity, slope of vt graph equal to acceleration, area of velocity time graph. From area of velocity time graph we can measure distance travel or sometimes displacement. Area under AT graph is change of velocity. Suppose this is displacement time graph given and three graphs are given. Graph number 1, graph number 2. So let's start. Let's discuss about the two graph. What is the graph denoted by 1? What is the motion described? Whose graph is given by 1? This graph means as time increases but its displacement remains same. Suppose this is a origin. So the position of the body or this body is here. Time increases but its displacement remains same, always same. That is body is at rest. The body is rest. So one graph denote body is at rest because time is already increasing but its displacement remains same. That means it is static or rest. So if body is at rest, then time increases but body its displacement will not change. So graph 1 denotes the body is at rest. Now what is the graph 2? Graph 2 describe uniform velocity. Uniform velocity because that graph 2 is a straight line. So this straight line means its slope is fixed. Slope is 1. So one slope means 1 velocity. We know slope of xt graph equal to velocity. Slope of displacement time graph is a velocity. So velocity is constant because its slope is constant. Same slope, no change. So graph 2 is represent uniform velocity. Now if a graph of a particle is given, now you have to determine the velocity at A, B, C. Suppose question is at which point velocity is 0. Second question, velocity at A and velocity at C, which one is more? Which one is more? That is displacement time graph is given at which point velocity is 0 and at A and C at which point velocity is more. So here this is a curve. So to measure the velocity at point, we have to draw the tangent. Suppose tangent at B is here, tangent at is like this, and tangent at A is like this. This tangent at A is like this. This tangent is parallel to T, so the slope of this line is 0. Slope of this line is 0 because parallel line means, so slope at B equal to 0, that is velocity at B equal to 0. Understand? Now at which point velocity is more, A or C? To know the velocity we have to know the angle. First we measure the angle. Suppose this is angle theta 1 and this is angle theta 2. This is angle theta 2. Now from graph you understand that which angle is more. Obviously theta 2 is greater than theta 1. Now tan theta 2 greater than tan theta 1. Now tan theta 2 means velocity at A and tan theta 1 means velocity at C. So from the graph we know that velocity at A greater than velocity C. So for a curve to measure the velocity at any point, we have to draw the tangent at that point. Now slope graphs are given. This is a graph and this. So this graph, this makes angle 30 degree, this angle is 60 degree. Ratio of acceleration, what is a1 is to a2? We know that slope of VT graph equal to acceleration, so a1 equal to tan 30 degree is to tan 60 degree, which is equal to 1:3. So this is the answer. Difference between position time graph, displacement time graph, and displacement time graph, position time graph, and distance time graph, distance travel time graph. Almost three terms are same, but there is a little difference. So we have to understand what is the position time, displacement time, and distance time graph. So to understand, suppose we consider the body is moving along x-axis. This is x-axis, here origin, and body starts from here. A body starts from here at here, which is at a distance, suppose a unit. At a distance, suppose a equal to 10 unit or something. So the body moves with a uniform velocity. Body moves with a uniform velocity. So if we draw the position time graph, I draw three graphs. Suppose this is position time. Position is denoted by r. Distance and displacement same. Position time, suppose this is displacement time. This is displacement time and this is distance time, displacement. This is distance time. This is distance time. So we have to understand the three basic difference of these three graphs. Now, how we draw the graph? You calculate the time and the distance from the origin. The position means its coordinate on the x-axis. So at time t is equal to 0, coordinate is a. So this is a. The particle starts from this and with uniform velocity. So the graph will be like this, straight line, because xt or rt graph, straight line motion is uniform velocity, denotes uniform velocity. Now the part at t equal to 0, the particle starts from here. So this will be the position time. After some time the position will be this. After some time position will be this. That is, position increases, time increases. So graph will be this. And what is the displacement time graph? Displacement, we measure the displacement from this starting point. So displacement time graph will be this. Displacement time graph will be this, and this slope and this slope same, theta, and here distance time graph will be also same. This is theta. So here displacement and distance time graph will be same, and position time graph start with this, because at t equal to its position is at here, but displacement, we measure displacement from this position, and distance also same. So displacement and distance time graph will be same if the motion is unidirection. Suppose direction is not changing, same direction. Now if the direction changes, then there will be difference between this and this graph. If direction changes, then this and this graph will be different. This, after some time, it reverses direction. Suppose this is 20 meter in 10 seconds, and this is 10 meter in 5 seconds. Uniform velocity, body moves with uniform velocity. Distance by time equal to 2. Here distance by time 2. So body moves with uniform velocity. So here it reverses direction. Now what is the displacement and distance time graph of this graph? Here displacement and time and distance time. What is the displacement time and distance time graph of this? The particles moves in this direction and reverse this direction for some time. So displacement for up to 10 seconds this increases. So this is suppose 10, and 5 second displacement again decreases, velocity displacement decreases. So this so this is total 15 second. This is 15 second. 10 plus 5, 15 second, and displacement gradually decreases. So this is the displacement time graph. Now distance always positive. Distance measure means what? Distance, this always increasing. This also increase. Distance has no direction. It is measured by the length measured gradually increasing. So the distance time graph will be like this way. Suppose this is 10, this is 15 second. So for this motion described, the displacement time graph will be this and distance time graph will be this. This is the difference, basic difference. This is velocity time graph. This is meter per second. This is second. Now suppose this value is 2 second. This value is 4 second. This is 6 second. This is suppose 10 origin. Now the question is here, what is acceleration at t equal to 1 second? T equal to 1 second. What is acceleration? What is acceleration at t equal to 3 second? T equal to 3 second. What is acceleration at t equal to 5 second? And last question, what is the distance travel? It is upward motion, so motion is unidirectional, but velocity from here decreases. From here velocity maybe decreases, but direction is same. As the whole curve is upward, if the curve drawn is upward, then we denote that direction of the velocity remains same, but it may that magnitude of the velocity may decreases or increases, but direction is same, like this. So velocity decreases, but direction remains same. Okay, what is the distance travel? In 6 seconds, or you may ask the distance travel up to 5 seconds. So these are the question. Now we know at t equal to 1 second means this represent this is 1 second. Now to find the acceleration, the point is at here, so the slope of this line represent the acceleration. As 1 second cut here, so cut here means at 1 second, if we draw a line, this is on the straight line. Now the straight line slope of the straight line represent the acceleration. So slope of suppose this is slope of OA equal to what? Slope means tan theta, tan theta, tan theta equal to perpendicular by base. Suppose this is perpendicular line, this to this is how? 10 by base. Base how? Base is 2. So 2 by 2, that is 10 by 2, that is 5 meter per second square. So this is the slope of line 5. This is the 5 and answer will be 5 meter per second square. Answer of 1 is this. Now what is t equal to 3 second? T equal to 3 second at which position? Suppose this is 3 second. 3 is cut on the line. So we have to find out the slope of this line AB. Now the slope, the line AB is parallel to the time axis. This is time. So its slope becomes 0. So answer of 2 becomes 0. Acceleration at t equal to 3 second becomes 0 as slope of line AB equal to 0. Okay, understand? Now t equal to 5 second. What is 5 second? 5 second is at here. So it cut this line. Now what is the slope of the line? The acceleration at t equal to 5 second. The slope is negative because this angle is greater than 90. So this become negative. Now what is the slope? Slope is perpendicular by base. That is 10 by base. Base is what is this value? 4 to 5 1 unit, 5 to 6 1 unit, 2 unit. That is 5. But this value is negative because velocity is decreasing. So this is retardation. Or you may think that slope of this line is greater than 90 degree. So if the slope is greater than 90 degree, this become negative. In trigonometry, greater than 90 degree value of the angle of greater than 90 degree, the tangent of this angle become negative. No, so this is minus 5. This is the answer. Negative. Or you may think that velocity decreasing, so it may be retardation. So negative sign. Now what is the distance travel in 6 seconds? What is the distance travel? We know from theory that area under VT graph equal to distance travel. Now we have to find out the area of this area of trapezium OABC equal to half sum of two sides means 6 plus this is 6 and this is AB. AB means 2 to 4. 2 to 4 is the AB. AB means this is the AB line. So 2 to 4, sorry, this 2 to 4 that is 2 into height. Height is, what is height? Height is 10. This, so this is, that is 40 meter. Area of this unit meter square, but as we know the distance travel equal to magnitude of the area, so this is 40 meter. Now if you are asked that distance travel in 3 seconds, then you have to calculate this trapezium, area of this trapezium. So this also half sum of two side into height. Now here height is this. Sum of two side. Now here height is this. Sum of two sides means this side, and height is this. This is second. Suppose this value is 10 meter. This is 4. This is 6 in second, and this is 2. Now the question is, what is displacement in 6 seconds? At number, what is distance travel in 6 seconds? Distance travel and displacement in 6 seconds. Now up to 4 seconds the graph will be upward, so direction is up to 4 seconds. Direction is in this way, in this direction. Velocity equal to 10 meter per second, and next 6 to 4 it reverses its direction. So 6 to 4, reverse its direction. 6 to 4 means 2 seconds. 2 seconds. It moves with velocity. Velocity is 2 meter per second. So the particle moves 4 seconds for velocity this 10 meter per second, and next, and here after 4 the direction is, the graph is below the graph below. So the that is velocity, the direction of the velocity changes, and it travels 2 seconds with velocity 2 meter per second. Okay. Now what is the distance travel here? We know distance travel means this area, this distance, this plus this. So distance travel and displacement is final distance, shortest distance between final and initial position. So this is displacement, and this is distance travel. Green color is distance travel, red color is displacement. So this, if the area is A1 and this is A2, so A1 plus A2, area of A1 plus A2 equal to distance travel. And A1 minus A2 will be displacement. So easily we can find the area. This 10 into 2 plus this is 2 into 2, that is 20 plus 4, 24 meter. Distance travel equal to 24 and displacement equal to 20 minus 4, that is 16 meter. So displacement is 16 meter and distance travel is 24. Distance travel will be this, that is this is A1, this is A2. We have to add A1 plus A2, and displacement is, this is A1, this is A2. So displacement is equal to this. So this is A1 minus A2. This is A1 minus A2. The up to this area is A1. Now from this to this area is A2. So distance travel equal to A1 plus A2 and displacement equal to A1 minus A2. The motion of the particle is given by this graph. Describe the motion of the particle. Is it accelerated motion or uniform velocity or retardation motion or what is at rest? Which one? So how we recognize the motion of the body given by this graph. This is xt graph given, and another graph, suppose v versus x is given this. So what is the type of motion of the particle given by this graph? We know here t equal to 0, x equal to 0, t equal to 0, x. We know x equal to ut plus half at square. If u is 0, then x equal to half at square. Now t square equal to 2 by a into x. Now here t we generally when we draw the parabola, this is x-axis or axis, and we draw the straight line or parabola or different curve. General convention of x-axis or axis, but here t is along the x-axis and x is along the y-axis. So this represent t square means x square. If we compare this, t is along x-axis, so put t as x, and this is a constant, and this is x becomes along y. So x square equal to ky. Now what is the graph of x square equal to ky? X square equal to ky graph will be this way. This is x parabola graph. X square equal to ky. Now the one part is given, this part is given. That is, if the graph is given, then this is a graph. This is a part of a parabola whose equation is this, x square equal to ky. Now this is k. So acceleration here, acceleration is constant. So that's why we denote that this is constant. So here acceleration is constant. Acceleration is constant means that is uniform acceleration. So graph, the motion of the particle is uniform acceleration. So if xt graph is this motion is uniform acceleration. Similar way, we know the equation of motion v square equal to u square plus 2ax. If u equal to 0, the graphs become v square equal to 2ax. Okay, the graph becomes v square equal to 2ax. Now v is along y axis, v is along y axis, so this is y square and 2a is kx. Now what is the graph of y square equal to kx? I have already discussed in parabola portion in coordinate geometry. Y square equal to kx graph is this way, x and y, this is y square equal to kx. One part of this is this, giving this, so y square equal to kx. So this is a part, these and these are same. So these and these are same means this is constant, this is constant, this is constant, this is constant means acceleration is constant, this is constant means acceleration is constant. So this graph also denote uniform acceleration. It is thrown vertically upward with a velocity v0 if the vertical downward direction is considered to be positive, then the correct variation of velocity with time is represented by four options are given. Another these options are given, so which one is correct? We have to explain this question. I repeat once again, if a ball is thrown vertically upward with a velocity v0, if the vertical downward direction is considered to be positive, that is we generally take g as negative, but here we consider g as positive, then plus g, then the correct variation of velocity time is represented by which one? Now, if a body is, answer will be this, if a body is projected with velocity v0, time of flight, time of ascending is v0 by g, that is after v0 by g, t equal to time of ascending, this, so this time we know v0 by g, this time we know time of ascending v0 by g, and time of flight is 2v0 by g. In all option these and these are given. Now which one is correct? So when a body is projected upward, then its velocity is maximum, that is v0. If we consider to be positive, vertical downward direction is positive, that is in this direction is positive, but this direction is negative. So at that time velocity is negative. So t equal to 0, velocity is negative. Here two option. Here velocity is negative. At t equal to 0, velocity is negative, and here negative. Now the body is projected upward, so at this point velocity becomes 0. At t equal to, so this becomes velocity 0, and this becomes velocity 0. This is v. So up to this all option are this, but when it moves its direction towards downward direction, that is after maximum height, when it travels downward direction, then that direction, then all will be positive, that is velocity will be positive, acceleration will be positive. Now the velocity positive means this velocity is positive, and the slope of VT graph, we know slope of VT graph is acceleration, so this is acute angle. Now we know tangent of the acute angle theta greater than positive if theta is greater than theta is less than 90 degree. So this is acute angle, so tan theta is positive, but here this angle is negative theta, minus theta. So that is slope of this line also, slope of this line is greater than 1090 negative. So when it reverses its direction, this may be positive. So along the two graph, between the two graph, here velocity is positive and acceleration is here velocity and acceleration both positive for this graph. So velocity and acceleration positive after it attains maximum height, that is when it reverses its direction towards downward direction, velocity and acceleration both positive. So positive here denote this graph. In this graph, velocity and acceleration negative. So the answer will be this. When it reverses its direction, that is when it moves downward direction, then velocity and acceleration will be positive. So positive value of velocity and acceleration is denoted by this graph, and in this graph velocity and acceleration is negative. So our correct option is this. Okay, this is AT graph given, AT acceleration versus time, this is meter per second square, this is second. Now a graph is given, this, suppose this is 6, this is 10 or 12 second. Now you are asked that what is velocity after 12 second if body starts with velocity 10 meter per second, that is initial velocity is given, then after 12 second find the velocity. So from this graph you have to find out the velocity after 10 second. Okay, sorry, you have to find from this graph the velocity after 12 second. Initial velocity is given, initial velocity here 10 meter per second. After 12 second you have to find the velocity. Now what is the theory? Theory is that here acceleration is decreasing. Acceleration is the value of acceleration decreasing. That is value of acceleration decreasing, but direction is same. Now we have to find the velocity from this graph. So theory is that I have written already the change. I have written the theory. The area under AT graph equal to change of velocity. Okay, so area, what is area equal to, area equal to half base is 12 into height is here 6, that is 36. So magnitude is 36. So change of velocity del V equal to 36. Change means final minus initial velocity, final velocity. Initial velocity is 10. So V final equal to 46. So this is the answer. And we always here, if no information is given, then you have to think that the direction remains same. If no another information is given, then you have to think that the direction is same, that is unit direction motion. So for unit direction motion, change of velocity is final minus initial. So that is answer. This is the answer. The here theory used area under AT graph equal to change of velocity. This is the theory. The transformation of graph will be discussed in another video. So this is the end of the class. Now student, to get such type of video, subscribe my channel. Okay, thank you.